we should finish. Let's finish this topic real quick. So in the introduction of circle properties, we had a discussion on what a circle is, what a chord is, what diameter is, what radius is. And we did our first circle property, which was properties of chords. And we did mention that if you draw a line from the center perpendicular to the chord, it bisects that chord. And we said two equal chords that are equidistant from the center are equal in length, and those equal chords, they subtend equal angles at the center. And we're able to do that question, which required us to use the Pythagoras theorem to sort of find the length of the chord. And we ended on this rule here, and I told you that this rule is very, very important. You have to know it. You just have to know all circle properties. But if you really want to remember a rule, it should be this rule, which states that the angle at center is twice angle on circumference, provided that they are subtended by the same chord. So this rule very important. What's happening? Okay, it's like it's frozen. Hold on. Okay, we're back. So this rule is very important, which says angle formed at center is twice angle formed on circumference, subtended by the same arc. So this is an arc. Remember, we defined an arc as just a small portion of the circumference. So you first have to identify that, okay, so that's my arc. Then you start following the angle. So this will be the angle formed at the center. So it has to be the same arc. So from there and there's that angle there, which is 2x. It's twice the angle formed on the circumference. And remember, they all have to come from the same arc. So angle at center is twice angle on circumference, subtended by the same arc. So let's move on to properties of angles in a circle. We continue. So the first one is angle at center is twice angle on circumference. And the second one is all angles that are formed in a semicircle are always equal to 90 degrees. Oh, they are always equal to 90 degrees. Okay, that's a new discovery. So what's a semicircle? A semicircle is just a region that's found within a diameter. So if that's the center and we draw a line dividing this circle in two equal halves, this one half will be a semicircle and the other half will be a semicircle. So this circle here is made up of two semicircles. So all those angles in a semicircle, they will always form 90-degree angle, and they have to come from one extreme point to the next. Like from the edge of the diameter, they have to originate from there. So this angle here that we've just formed will be 90 degrees. If we even draw another angle there, from there to there, another one from there to there, connecting it downwards. So it's not properly drawn, but you get the picture. So this angle here is also 90 degrees. This rule, don't forget it also. Angle in semicircle is always 90 degrees, because at times when we have questions in circle properties, they would require you to give reasons why you think that answer is. Let's say you know that you spotted, okay, they say maybe find angle x, and you say x is equal to 90 degrees. The examiner wants you to give a reason at times. So you say x equals to 90 degrees. Why? You say angles in a semicircle, angle in semicircle is equal to 90 degrees. So you also give a reason why you think this angle here is 90 degrees. Sometimes, actually most of the times, the examiner is going to require you to give a reason why. So the other rule that we're going to talk about is that angles in the same segment are equal. All right, there's an exam question there. Okay, that's good. Angles in the same segment are equal. So what do we mean by angles in the same segment? A segment is a segment is a region bounded by a chord and an arc. So if you have a chord like that, remember a chord connects two external points and doesn't necessarily pass through the center. So we've drawn our chord there. So this small chord here, you see this is a chord and that's an arc. That's a chord and this whole thing also is an arc. So we usually call this one here the minor segment. And then the bigger segment here is going to be called the major segment. So that's what a segment is. It's just a region bounded by a chord and an arc. So if you see such a pattern here, you just be like, okay, so angles in the same segment are equal. So what are those angles? So let's form some angles in this major segment. Again, they have to originate from that external point. So form an angle there. We form another angle there. Another external point, we go like so. Oh. So and we go maybe there. So these angles here are all in the same segment. Therefore, maybe this is angle X, this is angle Y. Because these two angles are in the same segment, we can say X is equal to Y. Then you give a reason, you say angles in the same segment, angles in the same segment are equal. Again, what's a segment? A segment is just a region bounded by a chord and an arc. A chord and an arc. So that's the minor segment and this is the major segment. Then you can say angles in the same segment are equal. So let's use what we've learned so far to try and attempt answering a question, an exam question on angles and circle properties. So here we have a diagram and it says in the diagram we have got BOA is the diameter. So BOA is the diameter, all right? That tells us something already. If that's the diameter, all right, I hope I'll be able to see this. Okay, I think I can see. Let me try drawing the diagram. Again, I didn't realize that this faint pen is going to end up looking like this during the presentation. So I've got a diameter here, and they are calling this diameter BOA. So let's identify that diameter as BO, which is at the center, and BOC. So this is diameter right there. And this diameter has formed an angle there from that external point to that external point, and another angle from this external point and this external point there. Already we know that because that's diameter, this is a semicircle and that's a semicircle, meaning this whole angle there will be 90 degrees. Maybe we will use it in one way, maybe we will use it in another way, we do not know. Then we can see that, okay, let me write this segment here as A. We can see that this is a chord, AB is a chord, and this chord is forming an angle there, and it's forming an angle there, and it's forming another angle there, meaning those two angles are in the same segment, so they'll be equal. So from A to C and from B to C, an angle has been formed by the same arc. So another angle is being formed here. And it's passing, okay, it's not passing through the center. And it's going from A to D and from B to D, but they are definitely in the same segment and they've been formed by the same arc, and they're in the same segment, and there's a chord there. So angles in the same segment are equal. So that's D there. And this is X degrees. And then there is another angle that has been formed with a radius, and it will definitely be an isosceles triangle because it's gone from the center O there. It's going from the center to circumference, so that says radius. And then even here from center to circumference, that's another radius, so it actually says something. So actually this looks like Y. So this is Y, and since this is angle Y, this angle here will be angle X, and this angle here looks like it is 60 degrees. So this is actually easy because I've actually explained everything. So we're trying to find angle X, angle Y, and angle BAC. Where is BAC? Oh, BAC, which is this entire angle there. So let's actually start with angle BAC, and remember you have to give explanations to why you think that's the answer. So angle BAC, this angle here, is equivalent to 90 degrees. Why is it equivalent to 90 degrees? Because the question stated that this line here, line BOC, its diameter, and this angle here is in a semicircle. So you have to say it's 90 degrees and you give an explanation. You say angles in a semicircle are equal to 90 degrees. So you say are equal to 90 degrees, like that. Then let's try finding angle Y. Angle Y will also be very easy to find because look at this. Let me use a color. This angle here, this 60 degrees, has been formed at the center of the circle, like so. And then another angle has been formed, like so. So you remember that rule, angle at center is twice angle on circumference, meaning this angle here that's at the center is actually twice this angle. So if I get this angle here at the center and divide it by 2, I'll be able to find angle Y. So we say angle Y will be equivalent to 60 degrees divided by 2, which is equals to 30 degrees. Y, you say angle at center, the angle at center is twice angle on circumference. Circumference, something like that. So this angle here is 60 degrees. Then the other angle here that we want to find is this one, X degrees there. How do you find this angle X degrees? From center to circumference, from center to circumference, meaning this triangle here, triangle OAB, is an isosceles triangle. An isosceles triangle, this side is equal to that side, meaning this angle is also equal to this angle. So if this angle is X degrees, meaning this angle is also X degrees. And remember, it's an isosceles triangle. And what did I tell you about angles in any triangle? Angles in any triangle add up to 180 degrees. So because this is an isosceles triangle, and meaning these two angles are extremely identical. If this is x degrees, the one that they want us to find, meaning even this one is x degrees. And remember, this is an isosceles triangle, meaning if this side is equal to this side, it means x is equal to x degrees. So all we have to do is just form the algebraic equation by saying x plus x plus 60 degrees is equivalent to 180 degrees, because all the interior angles in any given triangle will add up to 180 degrees. So this is now algebra. So this will be 2x plus 60 degrees is equivalent to 180 degrees. This crosses the equal sign and becomes a negative. So it will be 2x is equivalent to 180 degrees minus 60 degrees. So if we subtract 180 degrees, 180 degrees minus 60 degrees, it will give us 120 degrees. So 2x is equivalent to 120 degrees. We divide both sides by 2. That cancels. X will be equivalent to, so we divide by 2, x will be equivalent to 60 degrees. So even this angle here, x, is actually 60 degrees. You know these angles are 60 degrees. It's more or less like an equilateral triangle, but anyway, it's fine. So this angle here, x, is also 60 degrees. So this is how you use a variety of circle properties to answer an exam question. And I told you this one, the one that's in green, always comes. Angle at center is twice angle on circumference. Angle in a semicircle is 90 degrees, and then this one, it forms an isosceles triangle, so you have to form an algebraic expression and find the answer like that. So that's also 60 degrees. Okay, so let's move on to something known as, I'll send the video. It's just that my internet today was it was disturbed. My friend came and actually disturbed the MiFi, so have to try and reconfigure it once more. So let's talk about something known as cyclic quadrilaterals. So a cyclic quadrilateral is any type of quadrilateral in which all the vertices lie on the circumference. So what do I mean by all the vertices lie on the circumference? So if there is a cyclic quadrilateral there, like that's one vertex there, another edge will be there, another vertex will be there, and another one will be there. So as long as it's completed and all the vertices, so let's say this is A, B, C, D, all the vertices have to lie on the circumference. We can say that that's a cyclic quadrilateral. And any cyclic quadrilateral has got interior angles. So let's say this is an interior angle X, and this is an interior angle Y, and this is an interior angle A, and this is an interior angle B. Opposite interior angles in a cyclic quadrilateral are supplementary. It means that supplementary angles are any two angles that add up to 180 degrees. It means they add up to 180 degrees. So X and Y are opposite angles. So if we add X plus Y, we should get 180 degrees. If we add A plus B, we should get 180 degrees, because opposite angles in a cyclic quadrilateral are supplementary. It means they add up to 180 degrees. So imagine we draw an exterior angle here, like so. So an interior angle, let's say this is an interior angle Z, an exterior angle. An exterior angle in a cyclic quadrilateral will be equal to the opposite interior angle. So this angle Z will be equal to the opposite. So you go inside and you point to the opposite. That's the opposite interior angle. meaning Z is equal to X degrees. If it was here, let's say this is K degrees, you go inside and you point to the opposite. So meaning K will be equal to B degrees. If it was here, maybe this is angle L, you go inside and you point to the opposite, meaning L will be equal to Y degrees. If it was here, maybe it's K. You go inside, you point to the opposite, meaning K will be equal to A. So exterior angles in a cyclic quadrilateral are equivalent to the opposite interior angle. So you go inside and you point to the opposite. So those are cyclic quadrilaterals. So what do you have to know? A cyclic quadrilateral is a quadrilateral where all the vertices lie on the circumference. This one here is not a cyclic quadrilateral because this side is not on the circumference, so it's definitely not a cyclic quadrilateral. All the vertices have to lie on the circumference, and opposite angles in a cyclic quadrilateral add up to 180 degrees. They are supplementary, and the exterior angle of a cyclic quadrilateral is equivalent to the interior opposite angle. If I can know these things, and I'm not even writing an exam anytime soon, and I actually know these things. I've known these things since high school, and I was in high school around, I completed high school in 2013. So that's a very long time, and I still remember these things. So you have to remember these things also. Your mind has to be fresh. So this is what I was explaining. So let's go on to our last point, which is just tangents. At times, questions on tangents come, but there are just 2 points on tangents that usually come, which is, so a tangent, you are going to see when we do questions on quadratic function, because there are usually questions which say, find the coordinates of the tangent to the point at point when x is equal to something. So you have to sometimes a tangent can touch a circle, and sometimes a tangent can touch a curve, a quadratic curve that you draw. So a tangent is just a simple line that just touches a geometric figure at one point. So it's just going to touch that same geometric figure just at one point. And here, because we're dealing with a circle, it means a tangent is a line that just touches the circle at one point. So if I draw a line there and it touches the circle just at one point, that's going to be called a tangent. So that tangent there, this point there, so you've seen this tangent only touches this circle at one point, that becomes a tangent. Let me draw another one so that I explain the two rules on one diagram. So that's another tangent. Like so. Okay, this is a good tangent. So the first one is that a tangent that's coming from a tangent is perpendicular to the radius at the point of contact. So if I draw a radius here, so let's say that's the circle, and I go from radius to circumference at the point of contact here, it will meet the tangent at a 90-degree angle. So a tangent is perpendicular to the radius at the point of contact, meaning even this side here, if we draw another radius hitting this tangent there at the point of contact, that will be at a 90-degree angle. And then you see that these two tangents are originating from the same point there. So let's say this is point X. So two equal tangents originating from the same point are equal in length. So two equal tangents originating from the same point are equal in length, meaning in this tangent, maybe this tangent is AX and this tangent is BX, because they are originating from the same external point, it makes them equal in length. So just with this tangent question here, the examiners can come up with unique questions. They might make an angle there, and they might say find this angle there. They might say find this angle there. They might do that. They might do that. So they can do a lot of funny things, but all the questions are just going to come based on these circle properties. So let's now go to an exam question. So this is what I was saying, two external tangents coming from an external point are equal in length. Let's do this final question here. Hopefully I'll be able to draw it. Looks fancy, but this looks like a cyclic quadrilateral. 1, 2, 3, 4, all the vertices are on the circumference. So I think let's first start by drawing this cyclic quadrilateral. Notice how all the vertices are on the circumference. So that's one vertex that we're going to draw. All vertices will be on the circumference. So it has to tell you that, okay, I'm drawing an arrow. It has to show you that, okay, so this is actually a cyclic, quadrilateral. So that's another vertex there. Then let's draw the final two. The other one there. And something like that. So all these vertices, vertex 1, vertex 2, vertex 3, vertex 4, they are all on the circumference. Therefore, this is a cyclic quadrilateral. And here there's an angle Y there. And here there's an angle Z. Then let's look at this angle here that's been formed at the center, so that you can actually even see this rule, that the angle formed at the center will be twice angle on circumference. But this one, they actually wanted to be smart with this question. So they've said actually, to make it tricky, they put this angle here outside as 260 degrees. This whole angle here is 260 degrees. Then they've added another angle here, which is this 30 degrees? Oh no, it's W. They've added another angle here, and they have called it W. From there, passing through like that. And just extend it to there. Actually, can't I? Yeah, much better. Passing through like that, and the other one is hitting this arc here. Okay, so the diagram looks something like that. The examiners and I can't wait a question. So this angle here is W, like so. So the first thing that we should identify is we have to be able to find this angle here. when we find this angle here, things are actually going to be easy. And this angle here, to find this angle, we're going to use this angle property, which says angles at a point add up to 360 degrees. So we're going to use this rule. Angles at a point add up to 360 degrees. So if I had a point there and I had certain angles like that angle, that angle, that angle, and that angle, and let's say this is X, Y, Z, and K plus Z plus X plus Y will be equal to 360 degrees because they are angles at a point. Meaning this angle here and this whole 260 degrees will add up to 360. They are angles at a point. So if I want to find this angle here, I just subtract from 360. So I'll say 360 degrees minus 260 degrees. What are we getting there? Is it 200? So 360 degrees minus 260 degrees, 100. So we're getting 100 degrees, meaning this angle here is 100 degrees. Then we identify that circle property, angle formed at center, like so, is twice angle formed on circumference. Therefore, angle y will be 100 degrees divided by 2, which will be 50 degrees. Y, angle at center, is twice angle on circumference. Let me just rub this to give myself some working space. Then the other rule, we've identified, let's find angle W. So this is 50 degrees. So let me show you that. So this whole thing here, there's a chord there, there's another chord. So there are two chords there, and there is this whole region here inside. So this whole region inside is called the major segment, and angles in the same segment are equal. So this angle here going like that and going like that, this angle here and this angle are equal. So angle Y is equivalent to angle W because angles in the same segment are equal. So those two angles are in the major segment, so they are equal. Then angle Z here, we know that this is a cyclic quadrilateral because all the vertices, vertex 1, vertex 2, vertex 3, and vertex 4 are all on the circumference. And opposite angles in a cyclic quadrilateral add up to 180 degrees. So if I add Z and 50 degrees, so 50 degrees plus Z degrees should give us 180 degrees. So Z degrees will be 180 degrees minus 50 degrees. So 180 minus 50 degrees, we're going to get 130 degrees. Why? Opposite angles in a cyclic quadrilateral add up to 180 degrees. So once I send you this video, part 1 of circle properties and part 2 of circle properties, I already sent you the notes. You'll be able to just go through this video and revise this topic. Immediately you just know how to play around with the circle properties. This topic is going to become extremely easy for you. So let's end here for today. I have to configure the Wi-Fi so that I can send you this video. Then let me also attend class for teaching methodology. I'll see you tomorrow. I think tomorrow I want us to do, I hope I'll have energy. I want us to do the more concepts tomorrow so that we just start and finish the whole more concept. I really hope I'll be able to explain it from just start to finish so that you should be able to calculate questions with more ratios and concentration and limiting reagents and things like that. So I'll end here for today. I hope you've learned something, and I'll send both part one and part two of this topic immediately. I want us to do a lot of chemistry. Are you okay? I know this topic can be a little bit hectic, but you just have to just tell yourself that yeah, you will solve this. You just be focused. See the circle property, analyze the circle, look back. With this topic, by the way, if you forget the rules, you won't be able to answer the questions in the exam. So you just have to know the rules and you have to know how to answer the rules. So I'll end the class here and I'll send the videos immediately after I configure the Wi-Fi. See you tomorrow. We'll do some chemistry.